Okay, today is February the 10th, 2017, and right now at 9:30 p.m. in the foothills of Los Angeles, we have a temperature of 54 degrees. The relative humidity is 96%. We have a barometer reading of 30.04, which is up slightly, and the dew point is 53 degrees. We've had light rain all day. However, if we look at the MODIS Today map, we understand why the rain has been on and off all day. Let's take a quick look at the MODIS Today map, and we can see the brilliant natural white clouds here offshore. This is a moisture-laden natural cloud. We can determine that by the color. It's a brilliant white. As we pan east towards the shore, the west coast, we start to see the chemtrail mix. Now, notice how gray this stuff is. This is the chemtrail aerosol mix, and we can contrast that to the brilliant white right here, which is the frontal system moving in, the Pineapple Express moisture field moving in. We'll take a look at that here on the maps. But the main purpose of this is to be able to learn the color differences here on the satellite. This is the chemtrail. We can see the streaks. That's the chemtrail mix. As we pan further inland over the state of California, we can see the very, very heavy spraying operation going on. This is the Nevada border, and we can see those streaks all over the place here by out here in the Anza Borrego Desert. This is the Salton Sea, and we can see all those trails all over the place here. All right, so that is why the rain was spotty. We're seeing a little bit more here in the evening hours. We've had barely 3/8 of an inch, not quite 3/8 of an inch. Okay, so this is all chemtrail mix, and as we pan around, we can see the natural white, the brilliant white clouds right up here. Okay, let's go back to that first map. We have the infrared map, the Northeast Pacific infrared map. We can see the right angle right here, which is this is generated by a transmitter, a phased array type transmitter, which is breaking down this gale force system. We see the center of that storm right there, and look at these angles here. We have a perfect right angle right here, and look how well this envelope fits into that contour. It's perfect. And also notice what's happening here. I'm going to scroll through this. We'll back this up a little bit more, and we see that there's another separate rectangle right here. And that is because there is a counterclockwise developing system right here. So we'll go ahead and run the loop, and you can see that we have a weather system right here trying to develop, and they've got a transmitter right on top of that, and that's what that square box shaped contour is all about. So they force descending air right into this area, and that will stop the development of a new low pressure system right down along this long straight edge. By the way, when you put a ruler on this and measure the distance and then lay it right here on the Bay Area, this straight edge extends all the way to the middle of Kansas, right about here. That's a perfectly straight line all the way from the San Francisco area all the way out to the middle of Kansas. And the reason they're doing this with these transmitters is to separate this frontal system. We can see what's happening. There's a break right there. And actually, this whole side comes apart right here. We can see they're splitting it apart. And so what ends up happening is you end up with a low pressure system by itself without the associated frontal system, which ends up peeling off. And we get bits and pieces of this on the west coast. And this is what's bringing some of our rain. We can see a Pineapple Express flow here moving right into Southern California right now. If we look on the Doppler map, Greater Los Angeles is getting some rain. and also up further north. Now there's a unfolding disaster right now near, right up here near Oroville Dam area. Now there is some rain falling up near Oroville Dam. Here we go. Oroville's right there. I'd like to show you guys some pictures, everybody out there. Let's take a look at some of these pictures of the Oroville spillway, which has been damaged by inadequate maintenance. The water has gotten under the slab here. This is about a foot thick, at least a couple of feet thick, based on the size of these guys here. Very thick cement, and there's a huge sinkhole that's developed on that on this spillway right here. Now these pictures were taken 3 days ago. This one here, this is when the damage was first discovered. They shut off they closed the gates at the Oroville Dam, and they examined this problem. And because the dam is filling up so fast, they've had to decide to allow the water to continue to flow out, because there's no other way to get the water out. And so we can see the damage here. This is from, I think, yesterday. Right here we can see the water has been eroding the side of this mountain right here. So it's flowing part way down the weir, down the chute, the spillway, and most of it is coming out and moving down the side. All right, now this was taken late yesterday, and we can see that it's been completely wiped out. This is all bedrock, and they really have no choice but to allow more water to run down through here as the lake fills at the rate of about 6 inches per hour. All right, well, this was taken late yesterday as well, and the whole thing is destroyed. The whole spillway has been damaged, and you can see the erosion over here. And so they continue to allow water to run down that chute, but it's filling up so fast. And here we see it right here. This is the water flow. They're running about 35,000 cubic feet per second down this chute. It has a capacity, I believe, of about 100,000 or more cubic feet per second. And so the fact that they cannot utilize all that capacity down this chute, which means that that means that they will have to use an emergency spillway, which has never been used on the Oroville Dam. So that's a problem. So I don't know if everybody's hearing about Oroville on the news. We're not, but it's a major problem, because if that dam overflows, that's going to create a lot of problems. All right, here's the Northeast Pacific water vapor loop. We see that Gale force system with the right angle on it. And we've got high pressure installed right here, which is going to block a lot of this weather. Now, these weather controllers need to park this high over California for a few days and stop the rain, because Lake Oroville is filled up to the top, and it cannot withstand much more rain. It is right up near the top, and the last time I looked on YouTube, if you look this up on YouTube, they have a lot of videos, and the only alternative is to use the emergency spillway. Now, Oroville Dam is the biggest dam in America. I think it's the tallest dam. It's not the biggest, but it's the tallest. And anyhow, we'll ask that the weather controllers stop the rain for a while. They're getting too much up in that area. So rain is good, but too much is causing a lot of problems. All right, so here's the infrared loop. We see that Pineapple Express flow. It's coming down from near the Hawaiian Islands, and then moving right up towards Central and Southern California. Now, if you look at the, let's take a look at the Lotus today, and we already saw that. Here we go. the SSCC map. See a lot of high pressure, that clockwise rotation. And that may block some of this next weather that was forecasted to move in and soak northern California. We've got this Gale force system and another system right behind it. Let's take a look at the big map. Once again, we've got this thing with the right angle on it, and then this guy right up here. And we have something right down here trying to develop. Now, if we look at this same map again, we see something right here trying to spin. And we'll have to keep an eye on that. That is a low pressure developing right there over Northern California. Here's the surface analysis map. And here's that area of high pressure that's been put into place, installed to presumably block this next system. We'll have to ride up and over, and that may give Northern California a break, the people living in Oroville and near that area. Here's the swell report. We can see that Gale 4 system is generating 20-foot seas, 18 and 20-foot seas right out here. We've got 9 and 10, between 8 and 10-foot seas right off of Southern California. 6-foot seas right on the shoreline there, it looks like. Okay, so that's the report. And we'll just leave it right here. And once again, this is the form of climate change that the media doesn't want us to know about. Right here. That is a perfect right angle. That's not Mother Nature generating that right angle. That is a transmitter. It's most likely a satellite-based transmitter. And so this is the kind of climate change that nobody is being told about. This is modifying our weather and regulating the amount of rain that we get or do not get. Okay, so that's it. We'll do another update tomorrow.